I'm Megan Burns, a PhD student in the Department of Agronomy at Kansas State University and part of the SWCS KSU student chapter. Today, I'm going to talk to you about cover crops and phosphorus loss. So agricultural fields are a source of potential pollutants of different varieties, from the pesticides that we use to just sediment and soil loss itself, and then obviously nutrients that can come off of our agricultural fields as well. And today, what we're really going to focus on is phosphorus loss from agricultural fields. And the reason why this is a problem is because phosphorus that we lose from our ag fields can contribute to eutrophication and the development of algal blooms in our surface water bodies. So other nutrients are required for this process, but phosphorus is often the limiting nutrient. So controlling phosphorus loss from agricultural systems is really critical to being able to reduce eutrophication and algal bloom development in our surface water bodies. And this is important because obviously no one wants to go swimming under these conditions. So this really limits, or these processes really limit, our ability to use surface water bodies for our recreation purposes. So phosphorus loss from agricultural systems is a big environmental concern, and it is a threat to the sustainability of our ag production. So it's something we're really interested in getting under control. Along that same vein, we have been conducting long-term research at the Kansas Agricultural Watershed Field Lab. So this study was started back in 2015, and it's got a couple years left. But basically, we've got these pretty large plots. So they're about half a hectare in size. And you can see they're pretty large. So each one is its own large plot, but it's its own miniature watershed. So that means that we can collect runoff water, and you can see our runoff water collection units are all these white boxes here. So we have the ability to collect runoff water from each of these plots in our study so that we can look at the effect of the management practices that make up our treatments on surface water quality or runoff water quality, as well as obviously investigating the agronomics and the economics of these different packages of management decisions. So what we're focused on today is the effect of cover crop versus no cover. So all the cover crop plots are the green plots here. In terms of the types of phosphorus loss that we have from our agricultural fields, there's really two main forms. So what we're looking at in this picture is our runoff water flumes. So this is where the runoff water runs through, and we can collect a sample of that runoff water to do our analyses. And then we can also measure the amount of runoff that we've had and the rate of flow of that runoff, et cetera. So this is a real picture from one of those flumes when we were having a runoff event. And you can kind of see that there's sort of two components to that runoff water. So there's the water itself, which is going to contain, nutrients and other potential pollutants. Maybe it has some herbicide in it and things like that. Obviously, what we're focused on is the phosphorus, though. So there's going to be some phosphorus just in that solution component or in the water. And then you can also see that there's obviously sediment that's carried off with that runoff water as well. And there's going to be phosphorus that is bound to that sediment or that soil, in addition to the phosphorus that's just kind of hanging out in solution. So what this means is we have two different forms of phosphorus loss, and we call them particulate P or sediment-bound P, and that is the phosphorus that is bound to those soil particles. And then we also have dissolved reactive P, which is our solution P component. Both of these represent concerns for environmental quality and safety, but they're kind of at different time scales. So dissolved reactive P is a really acute risk because it's very readily available to microorganisms and can immediately start affecting our surface water quality. However, particulate P or sediment P is kind of this slow release form of phosphorus in our surface water systems. So both of them need to be controlled, and both are a concern, just at slightly different temporal scales. So do cover crops help manage our phosphorus loss? What we're looking at here is two of those flumes from a different perspective, and we can see the one on the left is from a cover crop plot, and the one on the right is from a no cover plot, and these images were taken on the same day. What you can really notice here is that the water coming off the no cover crop plot is a lot darker, right? It looks like it probably contains a lot more sediment. And this is what we would expect because we know that where we have a cover crop in place or where we have no-till, where that surface of the soil is protected, we're likely going to reduce our erosion losses of soil. So it would make sense that where we don't have the cover crop, we're losing more sediment. And like we just discussed, we know that phosphorus is coming off with that sediment that's being lost as well. However, something that's not depicted here, but we've been finding is we can actually have increased solution phosphorus losses where we have cover crops being grown. So while the cover crop practice is quite effective at keeping that soil in place and reducing soil erosion and particulate or sediment-bound P loss, in conjunction with that, it can lead to increases in dissolved reactive or solution phosphorus loss. Not in every case, but it certainly has the potential to do that. So when we're looking at incorporating cover crops into our system, what we really need to ask is, what's the main form of phosphorus loss that we expect to have? Because if a substantial amount of the phosphorus we expect to lose is because of the potential for severe water erosion in our system, if we're in a position where we have really intensive rainfall events and intensive runoff events as a result, or where we have a lot of slopes, maybe we're not in a no-till system already and our surface soil is really subject to erosion or at risk of erosion losses, cover crops could help keep that soil in place and reduce particulate or sediment-bound phosphorus losses as a result. But we have to kind of keep in the back of our mind that there's that other component of P loss, that solution P loss, that might be affected in a negative way when we have cover crops in place. So we want to look at things like how much soil movement do we expect to have, and what other benefits could cover crops provide to our system, because they're a really good conservation tool for several different purposes. They're just not necessarily a silver bullet solution to help our phosphorus loss issues. So really it comes down to evaluating cover crop use on a case-by-case basis based on your system-specific goals.